In fact, actually, even if you want to do a brief interruption during my talk, that's okay too. I'm okay with being interrupted, but I do need to stay focused and be on time, and I'm a big proponent of being on time. Can everybody hear me okay? I have such a loud voice, I almost don't need this, but I'll leave it on anyway. So, anyway, whatever that means, right? That might be what I talk about, we'll see. But I want to give you a little history, to just so you know where I come from and how that influences my thinking. So I evolved from this bunch of hoodlums, this group of people here. That's Professor Ralph Johnson, one of the Gang of Four authors, for the design patterns that we've all come to accept, and it's still like a bestseller book. And I did my research work at the University of Illinois Software Architecture Group in the early to mid 90s. And actually, that's Brian Foote, one of my colleagues that I wrote the big ball of mud paper with. And these two guys wrote the first commercial refactoring tools. And so I evolved from this group. And this group was really, we were committed, even before there was Java. And when Java came out, we were there. We got it and played with it. And we were really committed to what makes good architecture. How do you get reusable components? What kind of things happen when you develop nice frameworks? Reusability, how to get reusability in your code. And in fact, we were also looking at some meta-architectures even before meta was popular. However, in our software architecture group during this time, we also really noticed that it's very common that a lot of successful systems don't have such good architectures. And in fact, Brian Foote and I, we had just published a paper back then called The Selfish Class. And we were influenced by Richard Dawkins on the selfish gene. And imagine you're a piece of code, Java code or whatever, and you want to live. What kind of things can you do for that? And for example, we had some patterns like low surface to volume ratio. And that's where, okay, the surface, the API is easy to use, but it gives you lots of value. For a sphere is like that in the physical world. And then like general learning curve. The first one's free, riding on a winning team. These are some of the patterns, like the first one's free. If you can go out there on the internet, get it and try it, you're more likely to do it. And it's got to work out of the box. However, at the end, our big ball of mud paper kind of evolved. Sometimes software, a lot of code is really hard to reuse, and it looks more like these shanty towns rather than these beautiful architectures. I thought my career was over then. And then, lo and behold, though, I became dedicated to how can we really communicate and make better architectures. And part of that is even making it so the systems we're building, whether it's a developer or making it easier so the requirements adapt, we can more quickly adapt to changing requirements. Now, the cloud is related to that. So part of what I want to do to motivate this talk is to really kind of, let's take a little bit of a history. Specifically, maybe we can look at the major eras of computing history, or at least from the information age, if you prefer. And in the old days, back in the early days, you had these mainframes, time sharing, these mini computers, and pretty much it was only corporations that could really do computing, that could even afford this type of computing. And lo and behold, about the time I started really getting involved, we saw the big rise of personal computers. Personal computers came on, and you could get your Apple or your PC, and people like me could even afford to get one. And we started there towards the end of the 80s and the early 90s, cell phones started coming in, and web browsers. I actually was with people know who Mark Andreessen is? Mark Andreessen did Mosaic. Mosaic was before Netscape. It was like the first, at the University of Illinois, the first what we consider modern web browser. It was done at the University of Illinois around the 91, 92 time period. And before that, it was only us hackers and geek-type people could really get on and do Archie and Xgopher and all that other stuff, FTP. And then all of a sudden, these web browsers came around, and all of a sudden, it really opened up the whole thing. I mean, all of a sudden, computers became available to the normal person, whoever that is, right? And then, lo and behold, what have we seen lately is now everybody's got their nice little phones, their smartphones, apps. Apps are starting to become the norm. wherever I go, no matter which country I go to, even if it's a country that's very poor country, a lot of people with not much money still has their cell phone with their little apps. And it's all of a sudden opened up this thing to a whole new era. And so we've really changed, and we really need to think about that. In fact, this is a picture of a friend of mine from Brazil. He's a young guy, a professor, and he's into all these cool little devices, you know, that runs across the internet and can interhook things. And apps are becoming the main way that how we think about how things evolve and change. And because of the way that things have evolved and changed, we really need to rethink how we develop software. We have these evolving types needs. Because before we just had a bunch of servers or, you know, a PC or whatever, and the PC a lot of times was standalone, or you might put it on a network. But nowadays things are happening where we might have these apps or these different smartphones, devices, tablets, and we might be integrating with other corporate systems or going out there and getting a lot of things. So based on this, is things have evolved a lot. So as we're trying to connect all these devices, we're connecting things through the internet. And in fact, as things have evolved, a lot of cloud computing came up, what they're calling cloud computing in the last, 8 to 10 years. And some people have called it ubiquitous computing. I don't like the word ubiquitous so much. I like the word ambient, because ubiquitous means everywhere at once. Well, they're not everywhere at once. Ambient is, it's kind of there, it's all around us, but it's not prominent. We're not even aware, like ambient lighting. It happens, but so I even like the word ambient better. So it could be you have a device and I have a device and we're linked into some other wireless device somewhere else. So it is all around us, but it's not everywhere at once. And so I like the term ubiquitous. But the cool thing is what's going on with this, and things are taking off. And so cloud computing has become very accepted and popular because of this. So I want to talk a little bit about the cloud and how when you're developing in the cloud, especially software as a service, how metadata and meta-architectures are key way to do this. In fact, it's become the norm, it's required, and you'll have to do it if you really want to make good systems on the cloud. Now, cloud computing, there's a lot of miscommunication with it. What is cloud computing? And there's Wikipedia's definition. It's a delivery of a computing as a service rather than a product. Where shared resources, it could be software and information. So it could be you're making hardware available through the cloud, and I'm purchasing it from Amazon or whatever, and they're giving me some servers. And so they have server farms with extra bandwidth, and I can purchase that without having to install the servers in my facility, wire them all up. Somebody else takes care of that, and I'm purchasing how much I need, and I can shrink or grow very quickly. But similarly, it can be software. I'm purchasing email services or database services and growing things. So in the old days, when we think about traditional versus cloud computing, I remember before we were really getting into this cloud movement, you always had to have a large set of servers and your own backup, your UPS and everything else. And you really had to, there was a lot of overhead. You really had to take care of installing and maintaining these systems. However, with cloud computing came out, especially in the early days, when you could get the platform as a service and your infrastructure as a service, you could purchase these resources from the cloud, and then you could pretty much even maybe overnight scale your system. By here, scale might mean we need more disk space, or we need more bandwidth, more memory, things like that. And the nice thing is somebody else is worried. You didn't have to worry about the maintenance. You were purchasing from somebody that was expert and had a dedicated team for doing that, and you're getting that service. And so they're highly configurable because you can grow and shrink things quickly. Now, cloud computing, as it's kind of evolved, people's broken it down to these three major areas, though I will show you a fourth area. And we'll just cover it briefly so we're all on the same page, and then I'll get into the meta-architecture side. But platform as a service, software as a service, and infrastructure as a service. So infrastructure, here you're looking at more like hardware, servers, networking, backup, UPS, power sources, things like that. So if I want to purchase all this infrastructure, and maybe I'm going to install my own Oracle database on it, or whatever database I prefer, MySQL or whatever Linux operating system or whatever, I can purchase through the cloud some kind of infrastructure. And right now, I have some Linux servers running for my business out of my home. that I have installed, but I'm highly motivated to purchase some of these resources outside because I have to maintain this infrastructure and keep it up to date and all that. And maybe if I purchase that hardware somewhere else, they take care of the hardware and keeping it up to date, wired and backed up and all that, and I don't have to worry about it. Now, whereas when we think of platform as a service, platform is, now we're thinking things like virtual servers and resources. Maybe now on this infrastructure, somebody's going to already provide me a Linux box. It's already core Linux stuff I'm purchasing, and then I can start installing my specific software on that Linux box. And so that's actually, I'm going to take it a step further. I'm not going to just purchase infrastructure. I want to purchase platform because I want a Linux box, and I don't want to have to install and completely be responsible for always maintaining and updating because I'm too busy, you know, like being here in Poland at JDD or wherever. So right now when something happens to my server, I find out, and I have a lot of processes monitoring it. If I'm here in Poland, I have to be really concerned and get in and fix it no matter what time of day it is. Whereas with this, I don't have to worry about that. I can let people that are dedicated to doing that and providing it as a service to me at a very reasonable cost. Because before, I mean, in the old days, I loved to do it. I always had to have all my own stuff. But now it's becoming kind of a maintenance nightmare. And so why not purchase it from somebody that's expert? Now, what I'm more interested in, where this talk's going to do more discussion on, is software as a service. This is still fairly new. Some people are definitely supplying this, but there hasn't been a lot of work on this except in limited areas. But software as a service is here. We're going to build some kind of services that people can purchase. For example, maybe I'm going to build an online ordering system for Joe's Coffee Shop, and I'm going to have T-shirts and mugs and all kinds of stuff. But I want to take credit cards. But I don't want to be responsible for writing credit card security and credit card processing and talking to the banks. I can purchase that, which I actually worked with the company that we did this for. We purchased through the cloud people that provided as a service credit card processing because that was their expertise. They knew how to make sure they were meeting all the regulations and processing and security of credit card and the transactions to banks, and we were able to glue it together. And so there's a certain architectural style that works with this. But I mean, this could be a lot more than credit card. It could be for, you could start, for example, you might want to have inventory management or mail services or whatever. So with software as a service, this is really when we can start building our applications more quickly with this. Now there's actually these people, cloudcomputingpatterns.org, they're writing a book that's supposed to be out sometime later this year or early next year. And there's actually a lot of, they've already put a lot of patterns online. So if you go to cloudcomputingpatterns.org, you know, and I'll make these slides available, of course. But there they talk about having composite as a service. And really what they're talking about is packaging up a few of these. So you're going to build your software as a service with ways of building maybe multiple software services on different platforms and infrastructure and building it up so that you're making that available to your client. But the main thing, so anyway, that's some of the core information about how we think about clouds. I just want to make sure we're all on the same page. But when we think about scale, obviously scaling's already talked a lot through the cloud through performance and throughput. So we're already seeing that in the cloud right now. When you want more servers, when you want more bandwidth or memory, you can already purchase a lot of these resources. What I'm more interested in by scale, I'm not focusing on that. That's already there. What I'm more interested in is, hey, I'm a small independent person. I want to create some new service. I want to quickly get this up, and I want the barrier to be low. So I have a lot of friends, Java programmers, Ruby programmers, whatever language you want programmers. They can use the cloud to get and experiment and get something up very quickly. So they can make systems that are very adaptable, flexible, adapting to change quickly. They can get this up without a lot of overhead. By the way, I'm not really looking at reducing code bulk, but a lot of times these meta-architectures do happen to have a lot lower amount of code because you're leveraging different frameworks and other things for doing this. So I really want to scale you, the developer, on reusing what others have done, and you could build things quickly, plus possibly provide that for other people. You know, without having to purchase a lot of software, install it on your machine, or download it. You can just do it through the cloud. But Meta is key to that. So this is more what I'm going to be focusing on from scalability. So if people thought it meant scale the other, well, that's there, and I could talk about it, but I'm really interested in these other kind of things from scale perspective. And so metadata is very key. It's a technique for scaling these types of things. Because if I'm going to develop a service on the cloud, like credit card processing, and say I have 10 different customers, well, every one of them has different requirements, somewhat. So I may have to have configurations for you, and it's probably going to be different than the configuration I need for this other business customer here. So I need some kind of data, metadata, to describe those variances. And then if I all of a sudden want to have 1,000 customers, they all might have different ways and configurations and rules, and I need some ways of describing those variations. And that's where metadata becomes key for these types of architectures if I want to do that. So let's really think about the motivation here is parts of the business domain is either varying a lot because I want a lot of different kinds of customers. Maybe I want to do more than just the financial domain. I want to do also, I want to help people, I want to sell software for people within a lot of different domains, more than just coffee shops. Maybe I also want to do people selling online books or anything else for my credit card thing. So maybe I need different types of data to say the types of things they're selling and how to process that. So if the business rules and the elements are changing quickly, we need ways to be able to adapt this more quickly. And certain domains lend themselves very well for this. For example, financial, insurance, medical. I mean, there's lots of domains that's taken advantage of this even outside the cloud, but within the cloud, it's even becoming more key. And it relates back to me and Brian Foote put in our Big Ball of Bud paper is shearing layers. So as software, as parts of the system change more rapidly than other parts, and just like in a building. So this local space, the actual site where the building is, doesn't change very often. In fact, probably never changes, right? Whereas, in fact, the structure doesn't change much, but you might think occasionally we tear a wall out and extend it. But that doesn't happen that's not happening weekly. Definitely not, right? But you can think in here, they have ways where walls can change sizes. We can put new tables or chairs or new kind of lighting. So certain parts of the building can change differently. Similarly to our big balls of mud, based on our big balls of mud, we were saying if you could start separating what changes from what doesn't change, you can keep systems more clean. And so factor your system so that the artifacts that change at similar rates are together. And for example, the platform, you're not going to change that that's almost like the site. Whereas classes or new types of abstract classes and interfaces, once you choose a framework, you probably stay with it for a while. It's a little harder to change, but you can change it. Ultimately, code is pretty easy to change, but still there's a lot of things going on, and you have to test and validate it. But ultimately, if you can push it out into data, well, it's in a database or XML somewhere, you can change it very quickly. So in my youth, there was 2 bad words. So here's a picture of me in my youth back when I was a young developer there and doing stuff at the University of Illinois. And M and R words. And I don't mean relationships or marriage. I mean reflection and meta. So even though I liked it, a lot of the general programming population was, the performance is bad or it's too confusing and things like that. Fortunately, times have changed. In the last 10 years, especially, most of you are Java developers, right? You all use frameworks or you do web programming. You use metadata a lot. If you use JUnit, well, what do you think's going on inside that? There's a lot of meta description stuff. XML descriptions, you're sending stuff across the web. If you're using Hibernate or Sprint, all those other things, you're using metadata, whether you knew it or not. So fortunately, this is no longer such a bad word, that metadata and reflection have now become more acceptable today. And so let's think about metadata and then we'll look at how metadata can help us in the cloud. So, ultimately I get down that code is data, right? In fact, data is code. In our systems, we write Java as these different pieces of data that gets interpreted, and then there's a Java virtual machine that interprets it, and then we have a running system. In fact, everything is really data when you get zeros and ones when you get down to it on a computer, right? And it can drive behavior. And one of the problems with metadata And I had this problem when I was working at Caterpillar in the 90s, helping them with MetaArchitectures, because something as simple as part number for Caterpillar, they spent over a few million dollars with quite a few people years evolving their company when they had to change part number from one format to another because they bought a new company, for example. But imagine if you could describe things about part number, the description of part number and the variation in a system. Then when you need to adapt to something new, you can interpret that description, change that description. You can instantly reflect new types of things about part number. And I was always having trouble talking to these Caterpillar managers, you know, meta to the meta, the meta. What does that mean? You know, people start getting glazed look. And really, I got this quote from Ralph Johnson, which was kind of nice, and it worked well. If something's going to vary in a predictable way, store that description so that you can, it's easy to change and you can adapt it more quickly. And that's really what's going on a lot. And that's not all for metadata, but that's a good way of kind of looking at it. And meta-architectures are very useful in a lot of different areas. And in fact, we can start storing things about the types of things in our system, the types of objects we have, the types of attributes they need, the types of behaviors they have in their relationships, the rules. We can store these descriptions and maybe even some database or file or whatever, interpret them. And then when you change that description, so if part of your system, like Brian Foote and I said, separate what changes from what's not changing, if part of your system is changing a lot, take some of that, separate it into a layer, store some of that, if it's changing in somewhat of a predictable way, we can store those types of changes, like how you calculate an insurance policy. I know Hartford Insurance, they had the way that they calculated insurance policies back in the old days. They'd have to code those up. Now we have new types of risk based upon if you're under 25 or over 25, or if you buy multiple cars, and how should we insure you and how much we should charge you. Well, that changes, and they have to go write a lot of code and change code, and that would take many months, at least 6 months, sometimes up to a year. In fact, sometimes by the time they deployed it, that business rule was no longer valid because a new one had come along. They really need to change these in a matter of, really, they would prefer days, but definitely weeks, if not, you know, within a couple months. So by changing that description stuff about how to calculate an insurance policy into metadata, they could change that without coding. So then you could even make it sometimes with a DSL, a domain-specific language, they could make it so that you can change it even without programming. Now, I'm not considering using metadata to generate code, like the model-driven architectures or things along that lines. It's a related things. And I'm not really looking at building a stack of meta models and transforming between them. You know, the meta, the meta, the meta. I'm really focused on practical techniques for using metadata to scale solutions and making them more adaptable. Now, the problem with metadata, it's like the big elephant in the room. Depends on whose perspective that you're looking at. You know, are you really looking at the IEEE kind of definition, or whose product that you're buying, and other ways. So really, there's a lot of ways of looking at metadata. So let's kind of break it down. I like to break this down, and this is actually Brian Foote, the colleague of mine, did a talk last year in Brazil. We were down there, and metadata, the good, the bad, and the ugly. You know, and he even kind of played off the Clint Eastwood kind of movie thing with it, and it was fun. But really, we're looking at the 3 M's of metadata. And we call that meta objects is at the top, but you have these 2 core pieces that you build things with, markup and manifest. And so let's look at what metadata is about and how we can use it so to kind of put things in perspective. So for markup, we're all kind of familiar with that now. You can mark up data, we can use these different style sheets, and we have XML for tagging things. Now this has both a good and bad side. The good side is we can describe through this different markup and annotations different parts of our code, and that's kind of cool. On the other hand, it can become sometimes ugly. That's why I put this uglier piece, so that's kind of more the evil side, right, is from that. So that's kind of the bad side of it. But on the other hand, you can work on keeping this clean. And in fact, in our code, we see ways of doing these annotations from this. So in Java, it's very easy to tag different parts of your code. In the JUnit framework, they do ways of tagging your different types of tests, right, by annotating it, and then that way you can make anything a test. In the old days, you had to put test something as your method name. Now you don't have to. You can just annotate it, And then at runtime, you can interpret that and check things out and use reflection for that. So that's one type of one of the M's. Now, we do have the manifest. And the manifest is where we can add some extra descriptive information about the types of things that's going on. And that's also very valuable. And we can describe what's the legal set of types and other things going on. And then we might have the XML, the actual metadata that's going on that we're interpreting at runtime. But we might want to be able to actually describe from this perspective. And then finally, meta-object. Well, meta-object is when you really go meta. The problem with meta-object is it can be very hard to follow. And you need language designer skills to really do this well. But sometimes, because you're almost inventing a language when you go meta the meta, you really want all these new kind of complicated types. Those of us that are computer scientists or language kind of people, we love this kind of stuff, right? But sometimes, in fact, sometimes when we develop systems like this, we think it's the coolest thing. It's better than sliced bread or world peace, right? But then other people that come in that don't understand these types of principles, it can be very confusing. So we need to be careful. Fortunately, most of the time, you only need the two M's. Markup and manifest are good enough for most successful meta architectures. Though sometimes you need to go meta the meta the meta. And in fact, I claim anything that you can do, I can do meta. It's just one more level of indirection, right? It's the same way in computer science. So we can always make these things more complicated, but that's the danger. You should only be doing this if you have a real business case for doing this when you're writing systems, because otherwise you can make the system more complex than it needs to be. But if your business case is there, the win is huge. There's many domains where it's paid off tremendously when you get it right. And in the cloud, that's going to become key. And in fact, I'm going to show you a quick example with some Java code in the adaptive object model, which is an area that's been close to my heart since I kind of invented the term way back in the 90s, actually. But here we have classes, attributes, and behaviors. We can represent it as metadata, so we can change a new system. So we can make an object model adapted because we can store just the types of things in our system, the types of products and services I'm selling online, and all their attributes and the rules about them. We can store in XML or something, and then make it more adaptable. And if you go here at adaptiveobjectmodel.com, you can see a lot of papers and running systems, real-world systems that have been successful. And when you really look at the core architectural elements of these, which are similar patterns that you see in using Meta for the cloud, you see, well, obviously you have metadata. I've written a lot of papers on some of these, and so have other people. I've built some of these, and I've talked to a lot of other people that's built these for real-world systems. And you want new types of things, you can use a type object. There's the property patterns. For the sake of time, I won't go into detail because this talk is not on adaptive object models, which I could talk about. I just want to give you a feel of it. What really comes down to it, if you want something to change quickly, push that change even out of the code. Look at databases way back, whatever. Those are used metadata a lot, right? They have metadata for describing your types of tables, the rows and columns and all those other things. And then you can describe new types of things in that system quickly. And here's a common style. You can define new classes of attributes and relationships. Looked at many systems that's done these patterns. Here's the behavior. The behavior is always fuzzy because this is very domain specific and it always evolves. But this part over here, this is very common pattern. I've seen many of these types of meta architectures that have these types of type squared type things, whatever that means. I won't go into details, but just to give you an example, somebody took some of my stuff and wrote a Java example. If you go to codeproject.com, Christopher here, he shows how you can implement some of those types of things in Java. And it's not really that hard when you really look at it. Here you can define new types of entities and how those work, and you could tie entities into it. I mean, that was back from this where we want to define new types of entities, and it becomes instance-based rather than class-based. And you can even store the descriptions, and you have a little interpreter for interpreting this, so you can store this out into a database and realize new types of entities at runtime. And in fact, these things are very powerful. As your behavior varies, you can specify your rules in the metadata and interpret it. And just to show you that this is successful in a lot of domains, I've listed a few domains where very powerful systems have been developed. Some can be found in the papers on this adaptive object models. But insurance policies, telephony systems, workflow, medical, banking and trading, document management systems, so invoicing systems. And these systems can be very key to businesses that need to be, time to market needs to be quick, and the return on the investment where they can't wait a long time for this new type of change to come in. So if we can provide a way for them to quickly adapt and give them a nice way to adapt that, or even the developers can quickly adapt it by changing data for part of the system. Sometimes you have hooks for still writing Java code. That's one of our patterns, the dynamic hooks pattern, is sometimes you can't, you're not going to invent a programming language, so you want to just domain specific, but you don't do it all. So you might have hooks for adding new places where you can link in new Java code. And so really there's two ways of doing this as you're evolving. So normally when we have the traditional software architectures, when we have a new change, we definitely have a programmer who will make those change. Maybe you're doing TDD or Scrum. You have a new requirement. You break down these set of requirements into user stories. You break them down to small individual tasks that you can do during your next 2-week sprint. And you're going to do continuous integration and bring it back in. And so programmer writes a test, QA writes and runs acceptance tests. Ultimately, we get the approval. And at the end of each iteration, we can potentially update it in production. Usually there's a lot of bureaucracy on how you have to push things into production. But the difference is some of these adaptive architectures, sometimes the changes are one of the predicted types of changes we're working on. You don't even have to write new code. We can describe those variations, those new types of products, or now we want to sell sweaters at our coffee shop, and we want to have properties such as size and material and stuff. We can describe those new things without having to write code because we made a meta architecture that could describe it. And we could release these much quicker. And now, in the cloud, metadata is already used extensively when you're looking at low-level data, or file-level data. But the content-level data, this is what's growing. Like you might want to be looking at some more business level when you're looking at like a software as a service level from that perspective. Like, is the mammogram positive? Or what kind of products are you selling? And I'm giving you a way of managing your inventory. I need you to describe to me and provide an interface for you to describe the types of things you want to sell online, and I need to keep inventory for you. And so I'm keeping it in the back end. You want to build your app by plugging it together. So there's a lot of custom metadata that's going on in the cloud. In fact, with cloud component services, we want to make them highly configurable. Right now, the resources and stuff already is. But we might want to also configure the types of users I have, the types of roles they play, the types of processes, the workflow in my system. And so, and especially if I'm going to make a generic system that's going to work for more than just one specific user. I mean, if I have 2 or 3, maybe I can just keep doing releases every time I get a new user. But if I'm going to really scale up, try to provide this for a lot of users and be highly flexible, I need to really provide a way to adapt that. So with cloud development, maybe my application, I'm going to build my application here. And, and I'm a Java developer. I'm jumping in there. And the nice thing about the cloud is it's easier for me to, I don't care what language or platform all this stuff is done. I want to build an app, and other people have built through cloud services things about credit card processing or invoicing or inventory management. Now I'm going to build my custom app reusing a lot of these higher level services, software as a service. It's related to service-oriented architecture. The difference is on the cloud, I don't know anything. Service-oriented architecture was usually within my company, and I knew I could call you and say, how was this implemented, and we could agree and evolve the interface. Now with the cloud, that's different. You're providing a service maybe to a lot of different customers. I'm not your only customer. And so therefore, and there might be using whatever technology, Ruby, I don't care what technology. It's, you're providing a service. So I can build my app based upon that. But metadata becomes key because in my app, as I'm even talking to your systems and configuring things, I have to use metadata on there. So as I'm moving across with my cloud development, using metadata to kind of configure and build these, and I might even want my app to be somewhat configurable and adaptable as well with that. So clearly the people that are building these different services, if they want to make them adaptable to different environments, doing some of the techniques that I talked about with the meta architecture is how they're doing it. That's a key part, and it works well. I mean, it's a proven technology, and it's cool to see that it's finally become of age. And so now we can start gluing together my app by using some of that metadata, and I might even have a certain way, because my app might have to take and interpret some of that metadata and glue together different systems that were never meant to talk to each other. I'm using your service, and your service, and building my whole new app based upon that, and adding my extra domain-specific stuff that's proprietary to me from that. And so I need some ways of taking these different types of systems and gluing them together. And metadata is key to that. In fact, something that you commonly see is an architectural style, whatever these black boxes mean, right? Boxes never run, pictures never run, right? But it's really under the hood, if you really look at what's going on, is a lot of these systems that have some kind of services for these that they're storing, and they have some kind of ways of defining the processes or businesses, services from that, and you can really shrink and grow your systems and evolve them fairly quickly based upon some of these metadata descriptions. Now, I don't want you to just believe this picture. Let's look at somebody who's really done it. You know, let's look at SalesForce, force.com or whatever. This is some of their stuff. When you really look at some of their white papers and look at some of their architectures, I mean, they're using the cloud extensively, right? That's part of what they're selling you, some of these different types of services you can do. I mean, and they have ways of using all this metadata description and all these other types of things to build up my very specific types of screens or my specific types of rules, and I can define them based upon all this types of metadata that describes how my system's supposed to run. And so this has become a key, important principle on an architectural style when you're building these types of systems. Now, just because you're on the cloud now and we start building these meta-architectures, I mean, and what's important here too is, I don't want to overcomplicate it, it's important not to over-abstract or make it too complex. So sometimes it might be that your service is just varying a little bit. Well, that's all you want to provide me the ability to. Don't, you know, it's just like do the simplest thing possible with extreme programming or test-driven development. You do similar things here, is only provide me the flexibility where it's needed. If I make sure I have real scenarios to put the flexibility in. So we want to be agile about this and evolve these systems very similar to the way we think of what good design is. Don't over-abstract, you know, unless you have a real scenario or business case for that. So there's some issues you need to watch out for when we're dealing with this, okay? So just because you're doing metadata-based architectures in the cloud, well, with the cloud sometimes come some bad storms, right? It's more than just a rainbow and everything's happy. I'm still not sure why they used cloud, because that seems kind of fuzzy to me, but I guess it's just anywhere out there. But with the cloud is you definitely need some infrastructure for storing, building, and interpreting. So one of the fears back, at least in the 90s, back in my misspent youth when I was doing a lot of this work, is people were saying, oh, it doesn't perform fast enough. Whereas in reality, most of the time, the performance bottleneck is not interpreting metadata. It's usually reading values from a database or going across a wire or something like the bandwidth problem. So more of the problems are really somewhere else. And there's fortunately, when you do have performance problems, there's some well-known techniques, like what Java does in the Java languages, Java virtual machine, interpreted bytecode, things like that, right? So you can use those same well-known techniques for when you're dealing with this. Now, it does require good people. One of my goals has been to write about these architectures and describe it so that the barrier is lower, so if you're a developer and interested in this, you can see the best practices. What works, what doesn't work, what to do, what not to do. Also, the security becomes or validity. How do I trust you're processing credit cards? How do I trust you? I mean, if you're, of course, now, even if you're in my company, you could be stealing money, right? In fact, probably more theft goes on that way. But still, that's where you need, mainly you build a reputation and your business reputation, and maybe people validate you and go from there. And so, and how do I validate that what you're doing is correct? Well, maybe you have to provide things or have other people sign off for you and validate you. So some of these types of trust relationships are key and important for dealing with that. And how well is it tested? Can you prove to me that it's tested well and really does that? And you might have to provide extra infrastructure for me to validate you and test you if you're going to provide this. Additionally, you can, as I already pointed this one out, it can result in lower performance, but there's well-known techniques. I think this one's becoming another one. You can almost relate it back to the Microsoft DLL hell issue. People remember the DLL hell, all the versioning, the different COM. and you have similar issues here, is what happens if I provide a service, I'm providing it to all of you. Now I want to update because this group of people over here has this new kind of cool requirement I want to expand. They're thinking of the future. But some of you are late adopters. You don't want to adopt these new ideas over here because you're happy with the way your system's working. I can't just change my cloud service under the hood for all these people. I may have to handle versioning. In fact, maybe I have to use metadata to help me know who's using what version and which strategy to invoke and extra types of things from that. So there are some well-known techniques we can do that, but it's back to the old backwards compatibility, things we know about already. The difference is being on the cloud and being on the internet with our apps and everything else, things are happening much, much quicker. Things are changing, you know. We're not like we used to be. In fact, in 2009, social networking surpassed email. And a Gartner report pointed out that this year, 20% of businesses will own no IT assets. They're purchasing them on the cloud. And it's going to be as influential within the next few years, if not more so, than e-commerce. I mean, more and more, this is the way to go because it's cost effective, you can keep up to date more easily, and it's just a way to go. And then smartphones and tablets, it's surpassed PCs in sales. So now people want to build these types of things much more quickly. And the nice thing is cloud makes that a possibility, especially as we're evolving systems. And in fact, metadata is very powerful, a proven technique for doing this, for adapting systems to these types of changing requirements. And within the cloud architecture, one of the cool things about some of these types of architectures is the fact that when we're doing this, as cloud is becoming the norm, a couple things that's happened is even individuals can jump in. I have friends that, you know, they're just hackers on the side and, you know, young and lots of energy and wants to jump in. Well, in the old days, you had to have a lot of money. Right? Sometimes you can get some cloud resources in a limited amount to experiment with for free. You could build some application really quickly, some new app for the phone, and you could put it out there. And then if it starts selling, you can kind of scale it and do other things and adapt it much more quickly. So it's made the barrier to enter the market much smaller. So from that perspective of scaling, that's key too. And also meta-architectures, we can really adapt these systems much more quickly, and it's scaled in 2 dimensions. Not only rapid requirement changes, but we can leverage smaller team size. Most of the time I see people doing these nice, cool, adaptive systems. I have a good story of a company that did this in telephony domain. They had been doing this for years. They knew to bring up, so they had a marketing system on the telephony systems for cell phones, and they knew it would take at least a year or so to bring a new client online. They had experience. They'd done this for quite a few years. Their goal was that was too long. We couldn't really scale. How many programmers and big balls of mud are we going to create to do this? So they wrote one of these meta-architectures, and they reduced the time to market for a new customer from 1 year down to 2 months, less than 2 months, and that was their goal. So they were very successful. Their business grew 5,000% in the few years after that based upon this because they were able to adapt quickly to this changing thing by being able to describe these types of things. And in fact, they created what they call an AOM engineer, which became the domain expert that can work with customers and define new types of products. And they still had their main architects there. And the code base reduced from a couple million lines of code to under 500,000 lines of code. And believe it or not, that 500,000 lines of code is also the XML that's describing the systems. So that's tremendous gain. Another one is a Caterpillar system where they had changed their things like organization. They went from, they had a 1,000,000 line system that was core to the organization. All these other external systems used it. whenever they had a reorg, you know, all this system had to handle all that reorg within this big corporate structure. And it was 1 million lines of COBOL code. It was rewritten with 50,000 lines of Java code that did the same thing. So you can also scale by the fact that you need some good developers, but less developers on that. So how many of you in here have used Siri or know what Siri is? You know, the voice thing where you can go. Do you think all that runs on this? No. Well, how could you get that scalability and other types of things except through cloud-type architecture? Very little goes here, and it sends things across using some metadata and some descriptions and other stuff about the context, and it's sending all that back, and it's doing a mix of things. So, I mean, just think of that, is all of a sudden you need that other kind of horsepower. You don't have to go purchase all that. You can go out there and get some of that. So, there's even a lot smaller type things. So, as you can tell, this is a topic I love, okay? I get pretty passionate about it, right? And I love talking with people. I will say that for those of you that went to my pragmatic test-driven development talk with Rebecca today, I have the cycle as well as our 10 tenets up here. Feel free to take any of these because my suitcase did show up. That's why I have a different shirt on now. My suitcase was late getting in, but it's here now. But also, on there is information how to contact me. Feel free to contact me. I'm very interested in telling good stories and let's learn and evolve and share the knowledge about how to do these. And this has become key in the cloud. So hopefully I've motivated you. Cloud's here to stay whether we want to admit it or not. You know, just like when social networking passed email. I didn't think it would ever happen, but it happened, you know, and that's just how things are going. So things are evolving, and meta-architectures are a key part of that. So if you want to build systems, it's a good way of doing that. So I've definitely collaborated with a lot of other people doing this. So I have a list of some of their names. I have lots of resources there that you can check out. And there I am in Brazil, in Porto de Galinhas, nice place to go to a patterns conference. Had a fun time there. And really that's all so that's all I have, but I do have time for a couple questions, I think. Yeah, I have 3 more minutes. So I wanted to make sure to finish on time. So thank you.
Okay, thank you for your speech, and right now we have 10 minutes break.
We have a few minutes for questions if people have, because we have about 3 minutes. We have one right there.
Question? Okay. 1 second.
I had a feeling that you were talking about the metadata in metadata. I mean, you were talking very abstract about the metadata. So could you give some good practical starting point for applying the metadata?
Yeah, so for example, I'll tell you of in the last decade, about a few years ago actually, right? 2000, I had a team of developers and they brought me in because of my experience with building these adaptive systems. And something as simple as invoicing, they had to change for all their different clients. So they had all these different, how we're going to invoice you because you tell me how I have to invoice and break it down can be different than how you might ask me. So I needed ways to adapt that. So we could describe how we have orders in our system. So we could describe how to go and get those orders and how to calculate that and break it down, slice and dice it based upon some descriptive information about invoices. So mainly we took in with user stories, we could take and store that stuff, and then we could use some well-known patterns such as the interpreter pattern from the Gang of Four, or we were able to do things like new types of objects or new types of in the insurance domain. For example, you can define new types of insurance policies and with their calculation rules. So you provide some core primitives and ways of composing the composite pattern of building that up, but you're interpreting with the interpreter pattern or building these up through the builder pattern based upon the metadata description. That's really what's going on too when you have a lot of XML going across with the web, and it's building up, you know, when you have the DOM and all the other stuff, that says how to render that, right? So that's based upon most GUI descriptions are very much like that. It takes this description and says put GUI here, put figure here, put box here, put button here, and associate callback here like that. And so you have to write a little bit of stuff like that. But you have the meta description is based upon that domain-specific variations of how you have to do that. So I know it is a little abstract. I didn't have time, unfortunately, to go into a lot of concrete examples. If you look at our papers online, there's a lot of concrete examples, real world examples. And then that code project is kind of cool because it's a cool implementation of Java that you could just download and kind of run and play with. And I put some Java examples and other languages online with that as well. Okay? Maybe one more. Oh.
Don't actually have
I
time.
guess we are out of time now, sorry. But I'm here to talk afterwards, okay? So anybody that wants to talk to me
Behind the scenes.
Okay, thank you.